Introduction to Exception Filters in NestJS. Welcome to a lecture on Introduction to Exception Filters in NestJS. Today, we're going to look at how NestJS handles exceptions, the built-in mechanisms it provides, and how you can customize exception handling to suit your application's needs. Exception filters are crucial in creating robust applications as they ensure that unhandled exceptions are processed appropriately, providing user-friendly responses and maintaining the application stability. Built-in global exception filter. NestJS includes a built-in global exception filter that processes all unhandled exceptions. This filter specifically handles exceptions of type HTTP exception and its subclasses. So when an exception is unrecognized, meaning it is not an HTTP exception or its subclass, the built-in filter generates a default JSON response with a status code of 500 and a message indicating an internal server error. This mechanism ensures that users receive a consistent response even in case of unexpected errors. Additionally, the global exception filter partially supports the HTTP errors library, meaning any exception containing status code and message properties will be properly handled and sent back as response. Throwing standard exceptions. So NestJS provides a built-in HTTP exception class from NestJS common package, which is essential for creating standard HTTP response objects when certain error conditions occur. For instance, let's consider the find all method in the cats controller, where we are intentionally throwing a HTTP exception forbidden as a message and a forbidden status code, which is 403. When a client calls this endpoint, they receive a JSON response indicating a 403 forbidden error. So this standardized approach ensures that your API communicates errors effectively and consistently. Custom message and error cause. In addition to standard exceptions, you can customize the message and include an error cause in your HTTP exception. By passing a string in the response argument, you can override the message portion of the JSON response body. Moreover, you can pass an object to override the entire response body. There is also an optional third argument for providing an error cause, which is useful for logging and debugging purpose. So here's an example where we handle a service error. So error happens in this service find all method, and this is gonna throw custom HTTP exception with a detailed message saying this is a custom message with a HTTP status forbidden, which is 403, and providing an error cause. So this flexibility allows for more descriptive and informative error responses. Custom exceptions. While built-in exceptions in NestJS are powerful, uh, you may encounter situations where custom exceptions are necessary. By creating your own exceptions and inheriting the base HTTP exception class, you can define specific error conditions tailored to your application. So, for example, you can see that we can define a forbidden exception class that extends HTTP exception and use it within the find all method of the CATS controller. So this approach ensures that your custom exceptions are seamlessly integrated with NestJS's exception handling mechanism. Built-in HTTP exceptions. So NestJS provides a comprehensive set of standard exceptions that cover many common HTTP error scenarios. These exceptions are available from the NestJS common package, include bad request exception, unauthorized exception, not found exception, forbidden exception, and many more. I encourage you to take a look at these. You can also provide additional details using the options parameter. For instance, as you can see in bad request exception, you can include an error description and a cause for better error tracking and debugging. This rich set of exceptions helps you manage different error conditions effectively. Custom exception filters. Exception filters in NestJS give you full control over how exceptions are handled and the responses sent to clients. By implementing a custom exception filter, you can define custom response logic, add logging, and modify the response schema. So if you look at this example, we can create HTTP exception filter class that implements exception filter that is in NestJS common package, which is gonna catch HTTP exception instances and customize the response by including the status code, timestamp here, new date to ISO string, and request URL. So this approach allows you to tailor the exception handling process to meet the application-specific requirements. Binding filters. So you can bind exception filters at different levels within your NestJS application. There are three types of filters: method scoped, controller scoped, or global scoped filter. For method scope filters, you can use filters decorator directly on the method. So as you can see, we have use filters that creates HTTP new exception filter. And for controller scope filters, can apply the use filters decorator to the entire controller class. For global scoped filters, you can register the filter in the main.ts file using app.useGlobalFilters. So this flexibility allows you to control exception handling precisely where it's needed, whether it's for a single method, an entire controller, or across the entire application. Dependency injection in global filters. When registering global scope filters, especially when they require dependency injection, you should register them within a module using the app_filter token in NestJS core package. This approach ensures that dependencies are properly injected and managed by NestJS. In the example shown, we are registering HTTP exception filter as a provider in the app module. This method not only allows for dependency injection, but also makes the filter globally available across the entire application. Catching all exceptions. In order to catch every unhandled exception in your application, you can use exception filter without specifying any parameters in the catch decorator. So this approach ensures that all exceptions, regardless of their type, are handled by the filter. So the example you can see is shown, you can see uses a platform agnostic filter that works with any HTTP adapter. So by checking the type of exception and responding accordingly, you can ensure a consistent error handling strategy across your application. So extending base exception filter. In some cases, you may want to extend the default global exception filter to add custom behavior while still leveraging the base filter's functionality. By extending the base exception filter class, you can override the catch method and include your custom logic. For global filters, you can inject the HTTP adapter reference when instantiating the filter. This approach allows you to maintain a clean and consistent error handling mechanism while adding custom processing as needed. In conclusion, exception filters are a powerful feature in NestJS that enhance the robustness and user experience of your application. Exception filters allow you to handle errors gracefully, provide meaningful responses to clients, and maintain control over the exception handling process. So by leveraging built-in exceptions, creating custom exceptions and implementing custom filters, you can tailor the error handling to meet applications requirements. That's it for exception filter lecture. Thank you everyone for listening.